Hola, Mr. Lee here. We're going to investigate a really important inequality rule, and at the same time, just kind of see how we can manipulate inequalities similarly to how we do equations. Okay, so let's start with a very simple example, just an inequality statement with real numbers. So 2 is less than 3. We can manipulate this just like an equation. The only difference is instead of an equation symbol, it's an inequality symbol. So 2 less than 3, I don't know, add 3 to both sides. So 2 plus 3 is 5, 3 plus 3 is 6, 5 is less than 6. You can subtract 2 on both sides, 3 is less than 4. You can multiply both sides by, 4. It's going to be 12 is less than 16. You can even divide. Let's divide by 2, so that's going to be 6 is less than 8. Okay. So notice something. I manipulated it like I did in an equation, right? Do the same thing on both sides, keep it balanced. And instead of the equation symbol that carries through the whole thing, we have the inequality symbol. So the less than symbol carries all the way through. Okay, so here's where our rule gets applied. Let's look at a couple more examples. What happens if we multiply by a negative number? We're going to multiply by, let's do negative 3. Okay, so 6 times negative 3 is negative 18. 8 times negative 3 is negative 24. I'm going to keep the symbol there and analyze this. You should be saying, negative 18 is actually not less than negative 24, right? We have a problem. It's actually the other way around. So that's where this whole rule comes from. Whenever we multiply or divide by a negative number, we have to flip the symbol. So we're going to make it a greater than sign now, and now we're good. Okay, negative 18 is greater than negative 24. The world is right again. Okay, let's look at one more. I'm going to divide by a negative 2. Okay, so dividing by a negative number again, we're going to have positive 9. So positive 9 and a positive 12, and I'm going to keep the symbol. Same thing, right? We divide by a negative. Something weird happens. 9 is definitely not greater than 12, so we have to do the switch. So that's your rule. Whenever you multiply or divide by a negative in an inequality, you have to flip the direction to preserve the correctness of the numbers. Okay, so we're going to look at 2 quick examples applying this, and you'll see more complicated examples in your exercise, but just to prove this point, okay, I can add 3 to both sides, solving for m, right? I'm going to do this fairly quickly. That's going to be what? Negative 3, add 3 to both sides, and then multiply both sides by 3. That's how I undo the fraction. Negative 3 times 3 is a negative 9, okay? So in no step did I multiply or divide by a negative, so you just keep the symbol as it is. Straightforward, okay? And last one. Negative b minus 2 is greater than 8. I'm going to add 2 to both sides first. You get your negative b greater than 10. And then you have a negative b, which is negative 1 times b. So you can either multiply both sides by negative 1 or divide both sides by negative 1. I like to multiply. It's a little bit simpler. Okay, multiply by negative 1. That's where you get a positive b by itself and a negative 10 on the other side. And we multiply by negative, so let's apply our rule. We have to switch the direction. So instead of a greater than symbol, less than symbol. Okay, so that's what you'll see today. So get to it.